In this video for our interim review, I'm going over anything to do with our polynomials. So like the graphs and the factoring. So like here, for example, in number 1, if I want to know the number of zeros, but also the end behavior, then make sure to use Desmos, right? Graph is in Desmos, so you can actually see what that is. So again, graphing in Desmos, here, notice, here's our graph. So like I notice, for example, that we should technically have how many zeros? 5, which means in this case though, because we only see 3 real, because remember from fundamental, there should be 5 zeros. But because there's only 3 real because of where it crossed, that means that there are how many imaginary? 2 imaginary. So then the end behavior, that's your as x approaches infinity, what is your f of x approach? And as x approaches negative infinity. So again, going back, notice here, as we're going to the right, what's happening to the graph? It's going down to negative infinity. But on the left side, it's going up. So that's why here, we're approaching negative infinity on the right, but on the left, our graph was going up to infinity. Now, number 2. You just have to remember when listing the zeros in multiplicity, given the equation, the 3 is just a 3 value. That is not a 0. So I'm not going to even look at that. Now, if that said 3x, then times, let's say, x plus 5. Now, because there's an x value here, then I can say that x is equal to, well, negative 5 from our parentheses, right? But x is also equal to 0, because remember, this is like setting equal to 0. But because there was no x, 3 was just by itself, not a 0. So x is equal to negative 5 with a multiplicity of 3, because that was the exponent. Then negative 2 with a multiplicity of 4. Then x is 1 with a multiplicity of 2. And the last is, again, right, change the sign to 5. So now here in number 3, which function is odd? So remember the ends are going in opposite direction, not the same direction. So I can cross out this first one here because they're both going the same direction. And this one here is even as well because they're both going, the ends are going the same direction. So we have here going opposite, here going opposite. So these are odd. But which one is negative, which is going left to right down? The second one. So notice how we're going left to right down. So there's your negative leading coefficient. So in number 4, when you're looking for the equation, remember now, right? We need to change the sign. So if it's at negative 1, 2, and 5, I'm going to cross out B and C because notice the signs never change. Then keep in mind that at negative 1, we do have a bounce, which means this has a multiplicity of 2. So that's why the answer is A. Notice how you need the multiplicity of 2. So now in number 5, Isaac wants to sketch and has a total of 3 real zeros, which means it should cross the graph 3 times. So that total of 3 zeros. So like 1, 2, 3, and they're all slices, right? So 1, 2, 3. 1, 2, 3. Now notice this is a bounce. So even though that's 1, this counts as 2 because it's a bounce. 2, 3, 4. So nope. Here's another bounce, right? So that's a 2, 3, 4. And the end behavior, as x approaches positive infinity, so as we're going to the right, x is approaching negative infinity. The graph is going down. So as we're approaching positive infinity, which of these two graphs is the graph approaching negative? The first one. Notice how it's going down to negative infinity. So question 6, though, make sure to read, right? Because we're looking here. Oh, yeah. This one's just which one describes. So the leading coefficient is positive with an even. Nope, they're opposite directions. So this is odd. As x values approach positive infinity, the y values approach negative. Nope, they're going up to positive. As x values approach negative infinity, y values approach negative infinity. Yep, they're going down. That's why the answer is C. Now 7, though, you're looking for which statement is false. So the degree is odd. Well, so far so good, with a positive leading coefficient. So that is true, not false. Over the interval A to B. So from A to B, we're looking at this portion of the graph. It is below, so the values are negative and going down. Read it left to right. They are decreasing, so this is true. So then over the interval from C to infinity, so C and on, the values are increasing, yep, and positive, yes, because it's above. So that is true. So the reason why D is the false statement is because if you look at A right here, it has an odd multiplicity. Well, it's a bounce, and a bounce is 2, which is even. So now number 8, you just have to remember that this is, so like, let's say, for example, I want to know the degree. The degree is the exponent, right? So remember, degree, exponent, multiplicity. So here's 2, 1, 1. So this is a degree of 4. So I'm going to cross out, and I'm down to A or C. So now how many unique zeros? How many different zeros? Well, there's only 1, 2, 3. So that's why the answer is C. Then again, to get the end behavior, right? Just make sure that you graph this in Desmos to see that they are both ends were going up to infinity. So that's why the answer is C. Then number 9, which statement is true? Now notice how we're talking about over the interval 0 to 1. So from 0 to 1. So we're looking at this portion of the graph. Well, I notice, are these values positive or negative? Well, they're negative, right? Because they're below in the negative. So they're not positive, but negative. And then read it left to right, they are decreasing. So that's why the answer is C. Question number 10. There are 2 true statements about this. The maximum shows the skydiver jumped from a height. Well, no, the maximum is going to show you not where they jumped from, but the maximum height. So the answer is not A. The y-intercept. So the y-intercept shows where the skydiver jumped from. Well, yes, they jumped starting at 10 feet. So that statement is true. Local minimum shows that the length of practice section was 10.5 minutes. Well, the minimum is here, and that is definitely below, or 10.5 is here, but this is our minimum, because notice how it's even lower than this. So that statement is false. So then the x-intercept, well, is here at 15, which means that is the length of the practice section. Boom. They stopped here at 15 minutes. So that's why the answer was also D. And then 11 through 14. And then this is, oh, and then there's one more after this. Sorry, I'm going to do number 15 as well. So getting into our factoring. So again, remember when factoring our cubed roots, we need to know what is the A value and what is the B value. So like A is X and B is 3, right? Take the cubed root. So now we set up our parentheses. If this is a difference, then we take the difference. Then remember, A squared, B squared are always first and last. A squared is X squared. B squared is 9, because that's 3 squared. Now notice, because we already have our subtraction, now they're both addition. Then A times B in between, which is 3 times X, or 3X. Then same thing here, right? Take the cubed root. This is 2 cubes. So A is not just 2, but 2x. B is 5. So here, now when we set up, this is 2x. It's a sum, so 2x plus 5. Then again, A squared, B squared. Now, if A is 2x, then x squared, A squared is 4x squared. B squared, well, that is 25. Now, because this is a plus, now it's a minus, then a plus. Then A times B in between. So 2x times 5 is 10x. Now, factoring by grouping, we need to first notice here that the only thing that they have in common is x squared. So now I'm left with 1x, and then remember we took out the 2x's, so now it's just x minus 6. So that means I need x minus 6 in my other set of parentheses. So now what is it that we divide out here to get to this? -9. So I've got x minus 6 and x squared minus 9. Now, technically, I could take this a step further because if you were to solve that, you get plus and minus 3. Like add 9, take the square root, right? So that's plus and minus 3. So this is x minus 6 times x plus 3 times x minus 3. So basically, if you have that difference here and you can take the square root, you have the difference of those two perfect squares. So the square root of 9 is 3. So like if you had x squared minus 16, let's say, oh, that's a perfect square, right? Because square root of 16 is 4. So that's x plus 4 times x minus 4. So keep that in mind here, because like when you solve, you get the plus and minus. So like here, again, we're going to take out x squared. So that's x minus 2 now, right? Because we took out the x squared, which means now I need x minus 2. So what do we divide by? Positive 3. So I've got x minus 2 times x squared plus 3. Now, is there anything we can do with that? No, because that's a plus 3 here. So that is your factored form. So now I'm going to stop at number 15 because I'm going to do the optimization in another video. So 15 is which of the statements is true about the 0. So remember, this is like setting equal to 0. So if I were to factor this, right, I would take out x squared, and I'm left with x plus a, which means I would have in the other x plus a. But if you recall, if this is equal to 0, then really this x plus a means that x is equal to not a, but negative a, right? Because it's like we would change the sign. So not a, but negative a. So a is not the answer. So then here now, it is in factored form, the negative a. But notice how, can I take the square root? Well, yes, the square root of 1 is plus and minus 1. Like here, for example, x squared minus 1 is equal to 0. Go ahead and solve, right? We would add 1. X squared is equal to 1, but when we take the square root, remember, this is not just that value, but plus minus 1. Not just 1, plus minus 1. So that's why the answer is not B. So then here, looking at C. Again, you take out x squared. We're left with x minus a. That means x minus a. And then here, what would we divide out? -9. Now, again, keep in mind, right, this is still equal to 0. So I've got x minus a times x squared minus 9 is equal to 0. Now, notice that's x minus a, which means x is equal to not negative a, right, but x is equal to a. So far, so good. Then x squared minus 9 is equal to 0. Then we would solve, right? Add 9. X squared is equal to 9. Take the square root. Square root of 9 is plus minus 3, which matches. That's why the answer is C.